full building analysis solution, which is called Adapt Edge. Edge is for your multi-level gravity and lateral analysis, as well as the tributary load takedown feature that's a part of this Edge software. We also have an integrated column design option, which is only available with Edge. As of course the design of vertical elements makes sense only in the context of a multi-level structure. We will have a wall design feature available in the upcoming 2017 release of the software that's coming out in about the next month. Additionally, we have a foundation program called Adapt Mat. It's not limited to mats. It's really for any kind of shallow foundation system. So as you can see in the center image, you can basically model your entire structure, including foundation, have all of your loads brought down to the foundations for design. And today we're going to be focusing on this Floor Pro solution. This is the elevated analysis and design component of the Builder software, which is used for both PT and RC design of floor systems. So that can be a two-way flat slab, it can be a hybrid system, a waffle slab, a beam and slab system, transfers, and so on. So when it comes to the modeling and design of tendons and PT layout in your floor, you have a few different options. So in the US, predominantly, most engineers are probably using the effective force method, where you're assuming all losses have already taken place. You can also use a calculated force methodology to actually calculate friction losses, anchor set, and so on, to get a more precise picture of your tendon, especially along its length. Additionally, you can either lay out individualized tendons, or you can group them in idealized bundles. So for example, in this image here, you can see the banded tendons shown as a number of tendons, right? This is maybe 6 groupings of tendons along each banded line, but you could just as easily have modeled this as a single representative tendon, for example, that might consist of 30 tendon strands. You can model it both ways. And when you're modeling these tendons, these are true construction elements. So they are modeled from end to end, and they have a lot of information stored with each one. So for example, in this tendon, and those of you who are used to Adapt PT-RC might find this image somewhat familiar. It is kind of a duplicate in some ways, but it's important to note what's shown here. So for example, you can see that this end has a dead end, whereas this side is a live stressing end. You can see the CG values indicated. And here, for example, you have a section, this looks like a slab or beam section without supports, but there's a notch in the center of this slab here. So if you're using some other solution, it might be difficult to see where your CG point is referencing. And so here it's very, very clear. You can see exactly what you're referencing off of, what point of the slab is 4 inches away from your PT. And so that's really important that you have that transparency. Another thing to note is that the way we specify, let's say, or lay out tendons, it's with a CG offset from your extreme fibers at the top and bottom at mid-span. So in a case like this, you know, it's really nice if your slab section or beam section changes thickness, which of course happens over the course of your project design, that the intention of your profile will be maintained even as the slab section or beam section changes, right? So if you have this as, in this case, I don't know why 1.69, but if you have it as 1.69 here and 1.69 here, if your slab grows by 1 inch or 2 or shrinks by 1 inch or 2, your extent and shape of the profile will remain as it is. So with that, I just wanted to mention these few things, and let's go ahead and jump into the software, and then we'll kind of come back to that PowerPoint at the very, very end. Because this is a software demo, I wanted to jump right into the software. Oops, I'm opening the wrong version, excuse me. So I'm opening an internal beta release of the upcoming Builder 2017 version, which is scheduled for release next month. In primary focus today is this Floor Pro software, which I'll go ahead and open. So when you open Floor Pro, I'm just going to draw in a quick slab. Let's say something, who knows what, looks like this. And I'm going to now also draw a tendon, just kind of willy-nilly, to show you what we can do now. Let's say I'm going to draw a tendon, I'm going to curve around. Can you see this green line? My tendon is being defined by the mouse clicks I'm doing with the heavy maroon line, but as I move my cursor, I have a green curved line that's kind of following me. So this is a new feature, this spline display mode, where I can see what's a more realistic representation of my tendon shape. So that's one of the first new improvements in the 2017 version, is this spline shape. And so what's included in this spline shape is not just that it's shown for pretty pictures, which of course is nice in and of itself, but this tendon length is being calculated now in its entirety, and that length along the entire curvature is considered for example, elongation calculations and so on. So you're not just using, let's say this, if I turn that off, right, you can still use this. There's nothing wrong per se with doing this straight line mode, which we have previously made available, and you can always revert back to this way if you prefer to. But if you do use the splined option, then that's just going to give you a more realistic result. Coming back to these new tendon settings, there's a few other features here I want to mention. So with the spline mode, we also have an auto attach to slab edges and openings. So for example, if I zoom in over here, you can see there's kind of a blue-green X at the slab edge and tendon end intersection. And so what that means is that this tendon is automatically glued to the slab edge. So if I take this slab and I just move it some way, the tendon will move with it, right? And this, of course, I'm sure many of you are thinking about projects that you've worked on where the slab edge changes repeatedly, 6 inches here, 3 inches there, and so on, and the minutia of going through and actually grabbing all of your tendons and moving them back to the slab edge, this would effectively eliminate that extra work from you. Now, of course, if I wanted to orphan this tendon from the slab edge, I can just grab it and move it, and then any changes that I make to the slab edge will be completely irrespective of this tendon, and it won't change. But if I do want to bring it back, I can just simply move it over, and I can use a trim feature to just snap that back and reattach that connectivity. We also have a little double green arrow indicated here at a certain point away from the tendon end. So going back to my tendon settings, this is the auto swerve point. So the auto swerve point is saying based on some length of the tendon, whether it's a percentage of the tendon span length or some fixed length, for example 10 feet or whatever you'd like to use, there will be an inflection point. And this references to the angle that the tendon is going to be at its anchorage. So for example, if I click on this tendon, I now have not only the number of tendons in this general first tab, but I also have a first end and last end anchorage angle. So its default is 90 degrees, but for example, if I change this to 60 degrees on this first one, do you see how it will automatically change here? Beyond this, I even can go further, and let's say I want to modify this in plan using a quick mouse click. I can just go into the anchor angle, and let's say I want to change this to something else, and I just want to come in and change that anchor angle. I can do this by click. Okay, so obviously this is getting a little bit unreasonable, so maybe I just want to say, well, what would this look like if it's not fixed at all, if it's not constrained? Okay, so this is the natural curve that the tendon wants to take without being fixed at some specific angle. Okay, now here's a tendon shape that maybe I want to copy and reproduce. We have features to do that, but one new feature that's been added is just using Control-C. So I'm selecting this tendon. I'm just going to hit Control-C on my keyboard, which unfortunately you can't see. And now I'll just click out and hit Control-V. And do you see how now I have this tendon waiting to be dropped into place. So if I snap this, do you notice how I'm just hovering, I haven't clicked yet. Do you see how on the right side of my slab the tendon is away from the slab edge? So if I just click here and let's say copy this in, do you see how the tendon has automatically shored back and come back to the slab edge? So this is a really nice new feature that, depending on the kind of irregular layouts that our clients have in their tendon layouts of their floors, things are getting much more architectural and organic. And so in cases where you want to copy and replicate tendons, this program is becoming a lot smarter. It's going to be your best friend when it comes to laying out tendons. That makes a lot more sense over here. Now, I'm kind of just drawing freehand here, but let's say we have some other fun things that we want to do. So here's my tendon. If I look at the shape of this tendon, I've got some high points clicked here, right? I have a high point at these three interior locations, right? Here, here, and here. Now, let's say I want to remove this interior span. Maybe I'll just go ahead and make this kind of realistic. I'll put in a couple of columns. So my column is going to be 24 inches. Doesn't really matter. I'm just kind of getting something into the model. So let's say I have a column here and a column here. Now I want to take out this interior span. So the way I can do that is I can just simply click on the tendon, right click, and delete a vertex. I could just as easily insert one. So I'm going to delete a vertex and I'll just click on it, and now the program will automatically reset the shape of the tendon based on that. And if I look at the system, I see here that I have removed that interior span. For those of you who are current Floor Pro users, I'm sure you're loving and jumping up and down over this, that we've made this so much easier that you can just point and click. Another thing that we've added is, let's say we have an opening or some geometric reason that we want to swerve tendons. As it is right now, the only way that you can move a tendon is by its endpoints or high points, right? I can only, in 2016 and previous versions, move by those. So if I go ahead and let's say I'm going to draw in an opening right through these tendons here, all right, and showing you this shaded, you can see I have my slab and this nice opening right through my tendon band. So in an example like this, it's very easy for me to right-click on a tendon, and now I can insert a swerve point. So inserting a swerve point, I'll just click here and here. Do you see how now I have these little double-headed green arrows? So now I have a new handle that I can grab to move my tendon. If I zoom out, you can see now what's happening. And what's beautiful about this is that I have a tendon curvature already, right? There's a profile vertically of this tendon, and by me assigning these swerve points, I am not changing that profile at all. I'm just simply moving this in plan. So the horizontal curvature will respect the vertical profile that's already been established. All right, again, just moving this guy over here. Now we're starting to get a little bit crazy with that tendon, so we might want to come in and change our end angle and so on to get these shapes. But of course, I'm just freehanding this just to give you a sense of what you're able to do now with regards to adding points and swerve points and so on. So now I have this kind of crazy looking floor, but if you'll just bear with me here, let's go ahead and modify some of the things. Now, one thing that often comes up is you're looking on plan and you want to make modifications, let's say to the number of tendons or the CG value at any given location, and the way to do that has previously maybe not been as straightforward as people would have loved. So now we have a new feature to go ahead and make modifications. So by clicking on this dynamic tendon editor, I can modify the CGS value, the number of strands, or the anchor angle, as I showed you just a few minutes before, just very quickly in plan. So let's start with the CG value. By default, my CG has come in at 1-inch offsets at high points and low points interior spans, and then at the CG of the slab edge at the insertion and exertion points. So when I have something like this, let's say, all right, well, I don't really want to be at 1 for whatever reason. I want to be at 1.5. And so to do that, I can just simply click on any given point and it will update automatically. Or perhaps I want to window these 3 points and update them all at once. So you can see how this makes things a lot faster when it comes to, let's say, modifying a group of distributed tendons that you have on your plan. You don't have to go and click in on each one. You can just grab them. I can do the same thing over here. Perhaps I made a mistake. I want to come back to one. No problem. I can just simply go right back. Similarly, let's check out the number of strands. So strands are shown on the first point that the tendon was drawn from. So here I have my S equal to 1. These are all defined as 1 strand per tendon. So if I just want to change all of these to, let's say, 4 tendons, again, I can window them. Or if I want to just change 1, let's say back to 2, I can just click on this 1 and identify that. So this is really nice. Sometimes you have uniform tendons or distributed tendons that are in fact uniform and every one of them is the same. But often it comes to, you're really sharpening the pencil on it, so to speak, and you have to, change a CG point here or there, or change the number of tendons here or there, and this is how you can very easily do that in plan. I already showed you the way to change the anchorage angle. So again, let's say I just want to change one of these right here, and I'll just go ahead and show you how you can do that. Now, moving on, I'm going to jump away from this particular model that I have here into another one to start talking about some of the optimization features. So here I just have a slab set up with some support lines. I just drew in some quick X direction support lines on this slab. So one of the features that's currently available in our commercial release of the software is something that you can basically grab all of your support lines, and I'll just simply select by type. I'm going to grab all my support lines in this case here, and I want to optimize, I want to optimize my tendons in the banded direction. I'm going to assume that they're banded in this direction. So we have some features to do that. So you can use the associated tributary width. You can use some pre-compression range and self-weight balancing range. And let's say idealize these as 1 group of tendons or 2 groups, or space them. And then again, coming back to what I mentioned at the beginning of our session, where you can either use an effective force or the calculated force here. This is assuming an effective force per strand of what we use, 26.7. So if I go ahead and assume these and set these up, I now have these 3 bands of tendons. And so for example here, this is starting me off at 9 tendons based off of the values that I just set up. And if I go ahead and analyze this slab, and then I will also quickly design it, do a code check. And here we can see, okay, we've just done a very, very quick first pass. How close did that get us? So for example, from a top stress perspective, realizing, we haven't talked about loads or load combinations or anything. Here our top stresses are okay, our bottom stresses are okay, our pre-compression is looking good. This is just a quick first pass way of getting some tendons into the model. Now, let's jump out of this. I'm going to go back to yet another model that I have prepared. Let's say we've done a little bit more work on that same footprint, and now we have a floor plan that looks like this with some layout of tendons. So the first generation of a new kind of tendon optimizer is one where we can make some really nice and much more, let's say, targeted changes on our tendons. So let me show you what that looks like. I'm going to bring up the tendon editor and this new optimizer. Now, what I'm showing you right now in this moment is a first generation pass at this, and actually I'm going to switch to an image in just a moment because it's actually completely changed. The development team is working on the second generation of this optimizer, which is even more robust. But I just want to show you this first generation so you can kind of get a sense of what it's able to do in its current form and where we're going with it. So the optimizer, what it does is it grabs and automatically indicates a span for each of the tendons. So you can see these yellow handles have come up, and that's indicating a span. So for example, let's say this center group or band of tendons that I had looked at before, that was 9 tendons. So let's say I'm just going to window these tendons here, grabbing these yellow hold points. And so this is going to select these tendons and show me some tributary region associated with it. But I'm looking at this and I'm saying, you know, this tributary is really not correct. You know, if I turn on, for example, the tributaries that have been calculated here, it's going from here to here. And so just quickly, you know, getting a sense of what that is, if I'm just dimensioning this really quickly here, this is about 15.5 feet. So I'm going to actually change this tributary region to be 15.5 feet instead of 5 point whatever feet. So if I do that and update, so now my P over A happens, this is completely random, it happens to be at 125 right now. And this is, you know, so let's say I really want my pre-compression up at, you know, 200. Not that you maybe would, but let's just say as an example. So if I calculate that, this is going to tell me that based on this pre-compression requirement, I need to add a total of 4.13 strands, which is changing the selected strands that I have here by 0.83 strands per tendon. So if I zoom in and say these are all at S equals 1.4 for whatever reason, if I say apply, do you see how it's now changed each of these to be, in this case, 2.23 to match this 200 PSI pre-compression limit that I have specified. Okay, you could also optimize based on the load balancing. And so what happened, why this is the first generation and why we changed is we said, well, why are we only optimizing off of pre-compression, or why are we only optimizing off of load balancing? So now I'm going to switch back to PowerPoint. And again, I apologize that I'm not able to show this to you live. We're still in development on this. So the next generation of what this will actually look like is, in fact, quite a bit more robust. So taking your attention to this right-hand side image, where you can now enter your tributary width like I did before. You can specify, it's, let's say for your balancing load, whether you're balancing the self-weight or self-weight and dead load. And jumping down here, your pre-compression range, your load balancing range, and your CGS range. Let's say how far off from your soffit you want to be. And then this is really important, the priorities of your optimization. So in this case, we have 3 different parameters that you can optimize for: the stress, the pre-compression, and your load balancing. So in this example, you can indicate which one is the most important to you. So stress being, let's say, a code provision, maybe that's your number 1, pre-compression being second code provision number 2, and load balancing number 3. This is just as an example. Say in your case, maybe you don't care at all about load balancing. You could take that out and just optimize based on stress and pre-compression. Or maybe on the flip side, load balancing is your first pass how you want to optimize. So maybe you could reorient this so that load balancing is number 1 in your priority list. So you have full control and flexibility over the approach to how you're optimizing your tendon span. So now, all of those being said, I'm going to come back to this. This optimizer over here, you can see we kind of had something like this before, and now it's been really expanded. So when you select a span, the program will tell you what your total force is, the force per width, the total number of strands, and the average CG. And it will automatically calculate that without you having to do anything. If you make changes here or changes in the model, then you would hit calculate to update. Just like in the Adapt PTRC program, it's going to give you a quick heads-up status display for your pre-compression, your load balancing, and your stress to give you at a glance so you can see, okay, where am I on these parameters? Then you'll be able to indicate which load combination you want to optimize for and what criteria, meaning is it a 2-way slab, a 1-way slab, or a beam. And based on your selection, you'll be able to see the stress ratios for your top stress, pre-compression, bottom stress, and centroid at these A, B, and C locations. So A being the first section of your tributary, B being the middle, C being the end. And then any changes that you want to make, this is kind of a preview display of what will be optimized. So based on your dead load balancing percentage as well as stresses and pre-compression, you'd be able to see what those would look like and then hit apply if you want to actually make those changes to the number of strands. Additionally, the displays here are just shown as 0.0, but I do want to make a mention of the way that you can display the stresses here. So previously in Adapt PTRC, we typically display it in the factored way, which means, let's say your limit is for a tensile stress is 6 root F prime C. So the values here might be, 5.54 and 2.7 and so on, basically stripping out that square root of F prime C. If you change that to actual, it will tell you what the actual PSI value is, if it's 476 PSI or whatever. A new option that we're implementing is this ratio. So this basically says who cares what the ratio is, whether it's 6 root F prime C or 9 root F prime C or 0.6 times F prime C. Basically your limit is 1 is what this ratio assumes. So if your limit is 1, then what are your values? So here, if you're at 0.99 or 1.01, you know exactly how far away from your stress limit you actually are. And again, these are just options of how to display those values, which you will have the ability to change. So that really goes into the bulk of what I wanted to cover here to show you where we're going this. We want to make it much easier for you to close the stress gap in designing your floors. And let's say you have a new engineer or someone who's new to designing PT, we want to make it much easier and more intuitive to finalize your design to get to a point of completion and an acceptable design per code. So with that, I'm 1 minute under my 30-minute time, so I'll go ahead and pause here. I will keep the meeting open, so please do let me know if you have any questions or comments. You're welcome to use the chat feature, send me any questions that you have, or email me. If you're a current client, feel free to reach out to our support group as well. We're all here to support you. I hope you've enjoyed this session today. Thank you so much for coming, and I hope you have a wonderful rest of your day.